Good morning, everyone. I'm Varun, and I'm thrilled to welcome you to Team 24's presentation for CS6440. As someone who recently experienced a fractured arm and spent time in the hospital, I understand firsthand the challenges patients face in accessing and understanding healthcare information. During CS6440, our team embarked on a journey to address these challenges by creating a healthcare solution called Health GPT, which could be useful for patients, providers, payers, all three aspects of the healthcare systems. Before we dive into details, let me introduce you to the brilliant minds behind this innovation. Here's a talented team members who contributed to the development of Health GPT. Each bring a unique skill set to the project, whether it is generative AI, cloud, UI, machine learning, or even data analytics. Together, we recognize the pressing needs for improved accessibility of healthcare information. Let me walk the team through the problem statement. In today's healthcare landscape, navigating through the vast amount of data poses a significant challenge. Healthcare providers and patients often struggle to retrieve critical information efficiently. The issue stems from the diverse formats and applications used in healthcare data collection, from EHRs to insurance documents to FHIR servers, you name it, we have it. The need is to get this data in real time without going through heaps of documents. The need is to query and retrieve responses from FHIR servers in natural language via chatbot. And the aim is to make queries more interactive, result oriented, time efficient, and comprehensible for care providers and patients. Natural language queries reduces ambiguity and presents essential details in an easily understandable format. To address this challenge, our team envisioned Health GPT, a cutting-edge solution that leverages the power of generative AI and natural language processing. Our aim was to create a user-friendly platform that simplifies the querying and processing of information residing in FHIR servers. It incorporates prompt engineering and RAG to retrieve the information. The key features include natural language processing, prompt engineering to refine user queries, RAG implementation for enhanced response generation, and vector DB integration to reduce the cost and faster responses. The main benefits we see with this is improved health literacy and accessibility across different diverse patient populations, efficient retrieval of relevant health information, providing enhanced comprehension through natural language interactions, and empowerment of patients to make informed decisions about their healthcare. The goal is to use a bot to access the FHIR servers. What you see on the right is a small teaser of our application where we're using natural language to access this information directly from FHIR servers. Going forward, my team will go through the details of how this application runs.
Hi, I am Pramod Mishra, and in this section, I will be covering the project implementation status of our Health GPT project. While building the project plan, we have envisaged these 6 broad steps, right from environment setup to building the UI UX, integrating it with the vector databases, as well as doing the backend development. Finally, completing the whole app integration and conducting few end-to-end testing for patient records. In this whole activity, we have completed all the steps which we have planned. So we have implemented almost everything. We did some experimentation with vector base, and finally we were able to deploy all the planned activities. Thank you.
Hi, this is Sachin. I'm going to talk about the research that we have done for our project Health GPT. So first, we need to do some market analysis of all of the healthcare tech products that are available and what are the current gaps in those products and how using the latest technology we can solve those problems and fill in those gaps. So one of the things that we have identified during the research that there are a couple of EMR systems available in the market, but you need to do a lot of clicks and traverse through a lot of tabs to get to the specific information that the provider is looking for. It takes a lot of time, it's sometimes hectic, and it is not a very good experience for the provider when he is interacting with the customer and the patient as well. So to solve the problem, we did some research on the technologies and we have identified that GenAI can be the solution for this problem, where it can help generate text based on the specific questions and based on the model that has been trained on the data specific to the patient. To use the technology, we need to do some research on prompt engineering and the RAG architecture. Prompt engineering is very important for the GenAI models because prompt drives the LLM models what answer it is going to give. So there are multiple design to build a GenAI application. One is from a prompt engineering perspective, one shot, few shot, and RAG architecture. We majorly used RAG for this particular project, which means retrieval, augmentation, generation. So we need to first retrieve the information regarding the patient, augment the LLM with that particular information, and then generate the responses based on the augmented information provided to the LLM. We also need to do some research from the implementation perspective. So in the RAG model retrieval, how to retrieve the patient information. We use Happy Fire test server for a project. We pulled in patient medication, observation, and procedure resources from the Happy Fire server. Uh, and then from augmentation perspective, we need to give this information to our LLM model. So we use the vector DB. In LangChain, there is an option to use Facebook AI similarity search vector DB. So we use that particular DB for persisting all of these resources and do a similarity search and send the relevant information to the LLM model. From LLM perspective, we use the OpenAI GPT turbo model. So after fetching the specific information from the vector DB, we send that information to augment the LLM so that it can generate the required information for the provider. To tie all of these things together, we use the LangChain, which will connect all of the different components together. It helped us to integrate it with our web application as well, which is built in React and Node.js. From the deployment perspective, we used Vercel because that provided us a free option to publish our website for public usage. Thank you.
Good morning. Welcome to the demo section of our Health GPT project. This is a web application that is built on React.js and Node.js in the backend. In this application, we collect the patient information from the Happy FHIR portal data, and then we collect it and then we display here. So here, when we select a different patient, you can select patients, and here you can see the biographical data of the patient. And then for this patient, we can start asking questions about their details, like what is the, let me start with the basic question of what is the patient's address. So we got the address here. Now let's get into more details. Now we collect the medication details of the patient. So let me ask, what is the patient's medication list? It gives the information about their medication. Let me dig into more about their medication, like what is the dosage of the blood pressure medication the patient is taking. So it gives their information about the full information. Now let's see, are there any procedures the patient has underwent? It gives about their procedures, whatever they had gone through. And let me ask about the observations. Is there any observations recorded for the patient? It gives about their observation. So this is how we can use this application as a medical assistant for the patient information. And this application is deployed in Vercel, where we have divided into two components, a server component and a client component. The server takes care when the patient hits the ChatGPT communication, where it gets the data from the natural NLP processing, and then the client is where the React and the Node.js interaction are being done. Now let me show the code base. We have it deployed in. We have the code repo in our GitHub where we have it posted in the repository, and then let me show you the code base where we have a server and a source component. In the server, index is act as a server component where we have a send to OpenAI function, which actually consumes the information, contacts the AI, ChatGPT, and gets the information, customized information back. And then we have our client component, which builds in for the React UI. And also we have attempted to, we are connecting to storing the information in VectorDB, whatever they got using the FAI as using the LangChain integration. So all the patient information is stored in the VectorDB and then it's been played back. Thank you.
Greetings, everyone. I'm Courtney Simpson. Today, I'm excited to share the upcoming developments and future work for our Health GPT app, which we designed to revolutionize how we access and interact with health information. First, we're taking a big step forward with enhanced privacy measures. We understand the importance of security, especially when it involves PHI. We will be implementing robust authentication protocols to safeguard every user's data. Additionally, our systems will be designed to handle both PHI and PII with the utmost care, ensuring compliance and confidentiality. Next, to ensure our platform can communicate effortlessly with other health systems, we're expanding our app to support all FHIR standards. This will not only improve compatibility, but make our platform more robust and reliable for healthcare providers and patients alike. To address AI consistency, we're introducing a temperature setting feature to reduce the chances of AI hallucinations. This means more accurate and trustworthy interactions for our users. We're also developing a feedback loop system to guard against LLM poisoning, maintaining the integrity and accuracy of the information provided. Our final point of focus is in empowering our users. Health GPT will provide easy to understand relevant health information that empowers patients to make informed decisions. Through natural language interactions, we're not just providing data, but also improving health literacy and accessibility for our diverse patient populations. We think these developments are set to not only enhance Health GPT's functionality, but also ensure that our users receive secure, reliable, and actionable health information. On behalf of the entire Health GPT team, thank you for your time.